What if everything you know about reality, your life, your existence, wasn't real at all? Imagine waking up one day to realize that the world around you, the stars in the sky, the people you talk to, and even your own thoughts might all be part of a massive simulation. It might sound like science fiction, but what if it's not? There's a mysterious phenomenon in quantum physics called quantum entanglement that could prove we are, in fact, living in a simulation. This isn't just a thought experiment. Scientific experiments have shown that entangled particles can communicate instantaneously, no matter the distance between them, faster than the speed of light. How is this possible? Could this be proof that we exist inside a simulation, where the physical laws we're used to don't necessarily apply? When we think of simulations, we imagine computer programs or video games. But what if the universe itself is running on code? If quantum entanglement is a glitch in this simulation, then it may be the key to unraveling everything we thought we knew about reality. This may sound wild, but the evidence is stacking up. In today's video, we're diving deep into how quantum entanglement could prove that we're living in a simulated universe. We'll break down the science, the mind-bending possibilities, and the implications that come with it. By the end of this journey, you'll see the world in an entirely new way, one that's filled with wonder, mystery, and a deep sense of possibility. So if you're ready to uncover the truth behind our simulated universe, hit like and subscribe to join us on a journey through the mysteries of simulation theory. Let's get started. Quantum entanglement is one of the most fascinating phenomena in modern physics. But more than just a perplexing aspect of science, quantum entanglement might be the proof that we've all been waiting for, that the universe we live in is nothing more than a simulation. To truly understand this, we need to look at how quantum entanglement works and how it connects to the simulation theory. At its core, quantum entanglement is a phenomenon in which two particles become linked in such a way that the state of one particle can instantly affect the state of the other, regardless of how far apart they are. If one particle's state is changed, the other particle will mirror that change instantaneously, even if they are light years apart. This seems to defy the very laws of physics, which state that information cannot travel faster than the speed of light. This is where things get interesting. If particles can communicate instantly, it raises the question, how is this possible in a universe that operates under the laws of physics as we know them? Quantum entanglement appears to break these rules, and that's where simulation theory comes in. Simulation theory suggests that our reality is, in fact, a digital construct, like a highly advanced video game. And quantum entanglement might be a part of this code, a feature of the simulation that allows particles to talk to each other beyond the constraints of physical space and time. But why is this important? Well, if the universe is a simulation, the rules we experience might not be the true rules of reality. Just like in a video game, the world we experience is governed by the underlying code of the simulation. In this scenario, quantum entanglement might be a glitch or an intentional feature in the program, one that allows information to be exchanged faster than the speed of light. As we move through today's video, we'll explore how this idea fits into the larger picture of simulation theory and how quantum entanglement could be the breakthrough we need to prove that we are living in a simulation. The implications are profound, and the answers we uncover could forever change how we view our reality. The biggest challenge with quantum entanglement is that it contradicts what we understand about the laws of physics. Traditional physics tells us that information cannot travel faster than the speed of light, yet quantum entanglement defies this rule. Entangled particles communicate instantaneously, no matter the distance between them. This phenomenon is a fundamental challenge to our understanding of how the universe works, and it has puzzled scientists for decades. But what if this is exactly what we should expect if we're living in a simulation? In a simulation, the usual constraints of physics might not apply. We may not be dealing with a real universe in the way we think. Instead, the physical laws we experience could be the result of an underlying code, designed to mimic reality as closely as possible. This opens up the question, is quantum entanglement a feature of the simulation? It's not just a quirky anomaly. Perhaps it's a part of the design that allows the simulation to operate more efficiently. If information can travel faster than the speed of light, the simulation can synchronize its various components with ease, without having to follow the strict limitations of our known universe. But here's the problem. How do we prove this? How can we definitively show that quantum entanglement is evidence of a simulated reality? This is where things get tricky. As of now, there's no concrete proof that quantum entanglement is a glitch in a simulation, but the concept is growing in popularity. More and more scientists and philosophers are beginning to entertain the idea that we may not live in a natural world at all, but instead inside a highly advanced computational system. In the next section, we'll explore how quantum entanglement fits into the broader context of simulation theory and why it could be the key to proving that we are living in a simulated universe. Now that we've established the mystery surrounding quantum entanglement, let's delve deeper into how it might prove the simulation theory. Imagine for a moment that we are living inside a sophisticated simulation. The universe is running on a set of algorithms, constantly processing data to create the world we experience. Quantum entanglement could be a way for the simulation to keep all the particles and objects in sync, ensuring that everything operates in harmony. In a simulated world, the usual rules of physics may not apply. Instead, the system might be optimized to achieve the most efficient results, which could explain the strange behavior of entangled particles. If two particles are entangled, they could be linked through the simulation's underlying code. When one particle changes its state, the code updates the other particle's state instantaneously, regardless of how far apart they are. Think of it like a video game. In a game, objects in the environment don't interact unless the player observes or interacts with them. Similarly, entangled particles may only activate when observed, suggesting that they are part of a larger system that only updates when needed. This would explain the instantaneous communication between particles, as they are simply receiving and processing updates from the system. But the idea of the simulation theory doesn't end with quantum entanglement. It suggests that everything in our universe is governed by underlying rules. Rules that we may not fully understand, but rules nonetheless. If quantum entanglement is a feature of the simulation, it might be a tool used by the program to maintain the coherence of reality, ensuring that everything stays connected and synchronized. Now that we have a sense of how quantum entanglement could fit into the framework of simulation theory, we'll look at how these ideas could lead to a breakthrough that might prove the simulation theory once and for all. Here's where things get really mind-bending. What if quantum entanglement isn't just a quirk of quantum physics, but a fundamental clue that we are part of a simulation? This breakthrough moment could completely change our understanding of reality. If the universe is running on code, quantum entanglement could be the signature of this code. It's the way the simulation keeps everything in sync, processing and updating information faster than the speed of light. In this framework, quantum entanglement becomes less of a strange anomaly and more of a necessary feature of a simulated world. Scientists have already observed that quantum entanglement doesn't just break the laws of physics. It breaks all our assumptions about reality itself. It doesn't behave the way we expect the universe to behave. And what if that's because it's not the universe we're used to at all? What if it's a simulation, and quantum entanglement is simply one of its key features? This idea is supported by the growing field of quantum information theory, which treats information as a fundamental building block of reality. In this view, information isn't just something that exists in our world, it is our world. And if information is the foundation of the universe, then quantum entanglement could be the way that this information is shared and processed across the system. This isn't just a theory, it's backed by the latest developments in quantum physics and information theory. The idea that the universe is a simulation is gaining traction in the scientific communities, with more and more researchers considering it as a possible explanation for the strange behavior of quantum particles. To summarize, we've explored how quantum entanglement defies traditional physics and how it could offer proof that we live in a simulation. Quantum entanglement might not just be an anomaly, it could be a fundamental feature of the code that runs our reality. If the universe is a simulation, this could explain the strange and mysterious behavior of entangled particles. The idea that we are living in a simulated universe raises profound questions about the nature of reality. If quantum entanglement is a feature of this simulation, It suggests that everything we experience is part of a much larger system, a system governed by rules we may never fully understand. As we move forward, the mystery of quantum entanglement and its potential connection to the simulation theory will continue to captivate scientists and thinkers alike. But one thing is certain, we are only scratching the surface of a much larger truth. What do you think? Could quantum entanglement be the key to proving we're living in a simulation? Share your thoughts in the comments below. If you enjoyed this exploration of simulation theory, don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss an upload. And if you're ready for more interesting content on the simulation theory, make sure to check out our other videos. Thank you for watching.